Okay, today is Monday, um, April 23rd, and today we're doing trig ratios and right triangles. So there's a lot of vocabulary in this section. The first one is hypotenuse. Do you know which one is the hypotenuse over here? Hypotenuse is always crossed from the 90-degree angle, so let's write the word hypotenuse here. According to, you have to pick an angle here. Both of these other two sides are called legs. They're both legs, or I should say leg and leg. But they have a special name. They're either opposite leg or adjacent leg. And it depends which angle you're going from. So you have to pick an angle. You guys want to go from angle A or angle B? Let's go from angle A. Circle angle A. So if you're going from angle A, this one straight across is called the opposite leg. And then this leg would be the adjacent leg. Now adjacent means next to. So angle A, adjacent, so that means side B is adjacent to angle A. Now, if you would make another triangle over here, hypotenuse, let me say this is BAC. We know that's the hypotenuse. What if I said go from angle B? So what if I circled angle B? Now, opposite now is over here because it's across from B. So that's different than this first one. The first one was adjacent. But it depends what angle you're going from. So this is the opposite leg, and then this is the next to, or adjacent leg. You see how this is next to B? It's the closest one to B. Adjacent's always one touching the angle, or forming the side that forms the angle. So, you've probably been hearing your whole life, SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. This table shows you all of these things, and you can just kind of look over there. But I like to abbreviate this a little bit off down here to the side. You need to know that, for example, the cosecant is the reciprocal of sine. It's kind of hard to tell that in this table because they're like in 1, 2, 3, 4, 5, 6 thing. So what I like to do is the three main ones are sine theta. Let's see if you can see this here. Sine theta, cosine theta, and tan theta. Those are our three main, right? Let's go ahead and put in there. So we got SOHCAHTOA. Don't forget, I'll write right here again. SOHCAHTOA. So sine is OH. That means that, okay, then cosine is AH, adjacent of hypotenuse, and tangent is OA, so it's OA. Their reciprocals are cosecant, and it's abbreviated CSC, theta, and since sine is OH, cosecant is HO. So you don't really need a mnemonic device for cosecant, secant, and cotangent because you just have to know these three. If you know these three are just the flips of them. This one, the reciprocal of cosine, is secant, so it's SEC theta, and it is HA. It's the flip of AH, so it's HA. And tangent is OA. Its reciprocal is cotangent, which is abbreviated COT. Look up in the chart. And that is AO. So this is how I go. I think of them this way versus looking at this big table of 6 with all those words. Okay, so if you can remember this, you're good. So remember, sine's reciprocal is cosecant. See how there's no co here? This one has a co? Each pair has to have a co. There's no co out front of sine. It's a sine, so its partner is cosecant. Cosine starts with a co, so its reciprocal should not have a co. Secant. This one doesn't have a co, so its partner reciprocal has a co. Cotangent. Okay, so in example 1, you have to find the values of sine, cosine, and tangent, so let's get that ready. And it says for angle B, so we're going to go sine B, cosine B, and tangent B. All from B. Remember, sine is OH, cosine is AH, and tangent is OA. I sometimes write those just to make sure I don't mess up. Keep that in mind that that's what that is. And then we need to come over here to the triangle and circle angle B. Now, it looks like we know two sides, but we have to find our third. So one more thing you have to know is the Pythagorean theorem. So it's leg squared plus leg squared equals hypotenuse squared. If you put it into words, which is the same thing as x squared plus y squared equals r squared. So legs. The legs are 8 and 15. Hypotenuse squared. So it's 64 and 225, which is 289. And if you take the square root of 289, you get the hypotenuse being 17. So we're going to fill in the 17 right here. This is 17. So you might want to fill in words like this. From B, 8 is the opposite side. 15 is the adjacent side. And 17, of course, is the hypotenuse. Keep those in mind when you're doing this. So what is the sign of B when it is opposite over hypotenuse? From B, opposite is 8 over the hypotenuse 17. So it's 8/17, that's your answer. Cosine of B is adjacent, which is 15, over the hypotenuse, which is 17. So it's 15/17. And tangent is opposite, which is 8, over adjacent 15. So it's 8 over 15, and you're done. Now this one, secant and cosine, if you look at over here, it's my chart, secant and cosine are reciprocals of each other. So if it says that secant is 6/5 and they want cosine, the reciprocal of 6 over 5 is 5 over 6. So cosine of theta is 5 over 6. It's the flip of 6/5. Now in this one, sine and cosecant are reciprocals. It's right here, sine and cosecant. So you can't flip a decimal. So on your calculator, punch in 0.8 and then math, enter, enter. Tell me what you get. Did you say 4/5? You're right. Good job. So what's the reciprocal of that? If sine is 4/5, then cosecant is 5/4. That's your answer. Find the values of all 6 trig functions of E. Let's circle E. And before we can do that, we need to do the Pythagorean theorem. So this is a leg, this is a leg, and we're looking for the hypotenuse. So we have 3 squared plus 7 squared equals the hypotenuse squared. So it's 9 and 49 equals the hypotenuse squared, which is 58 equals the hypotenuse squared. So if you square root, your answer is square root of 58. Now, the hypotenuse is radical 58. I tried, let's see, 58 factor tree is 2 and 29, and you can't factor 29, so this cannot be reduced. So we're going to put a radical 58 in the hypotenuse. Okay, according to E, 3 is the opposite leg, and 7 is the one that's right next to it, so that's the adjacent leg. And we know that the other one's the hypotenuse. This time they want all 6 trig functions. And I will write this for you on the test. I will say sine E equals, cosine E equals, tangent E equals. And then right next is, I'll write cosecant E equals. The reciprocal of cosine is secant. And the reciprocal of tangent is cotangent. So I'll have all this set up for you ready to go. Like that. Sometimes it might be helpful if you write OH next to sine and AH next to cosine and OA for SOHCAHTOA. That sometimes is pretty helpful. So sine is OH. So let's look at our triangle. OH from E. O is 3. H is radical 58. So it's 3 over radical 58. If it wasn't the end of the year, I would have you rationalize that. But right now, we're going to keep it as 3 over radical 58, which means the cosecant is radical 58 over 3. Just flip it. Just flip it over. Cosine is AH. So adjacent is 7. Hypotenuse is 58. So we're going to go 7 over radical 58. Again, it should be rationalized, but I'm okay if you just write 7 over radical 58. Therefore, the secant is the flip of that, which is radical 58 over 7. And the tangent of E is opposite over adjacent. So it's 3/7, which makes cotangent 7/3. 3/7, 7/3. 3/7, 7/3. Done. Now a little bit about 30, 60, 90 triangles. If you have this 30 degrees, that means this is called the short leg. The shortest leg, because the shortest leg is across from the smallest side. This is kind of hard to see. Sorry, guys. The short side is across from the small angle. Short side is across from the small angle. Across from the 60, this is called the long leg, and that's across from 60. The 2x is the hypotenuse. It's the longest leg, but we don't call it that. We just call it the hypotenuse because everyone should know the hypotenuse is the longest leg. Now they use x, 2x, and x radical 3, but in terms of numbers, I like to think of it as a 1. If the shortest leg is 1, the hypotenuse should be double the short leg. Double the short leg. So if the short leg is x, double that is 2x. If the short leg is 1, double that is 2. So you can think of it with x's or just numbers. If the long leg is, if the short leg is x, the long leg is radical 3 times the short leg. So you would say that this is radical 3 times the short leg. So this would be, if this is the short leg, then the long leg would be 1 times radical 3, or just radical 3. So let's do a little one off to the side. What if this was a 5? The short leg was 5. What is the hypotenuse if it's double that? 10. You are right. Now what's the long leg if it is the radical 3 times the short leg? Well, you take the short leg 5 and you multiply it by radical 3. And that's how you'd fill in your sides. So what about a 45, 45, 90? So these are XX radical 2. This is a leg, and this is a leg. They're not short and long. They're the same because this is isosceles. So if you have two 45-degree angles, their legs are the same thing. The hypotenuse is radical 2 times a leg, either leg. They're the same thing. So the hypotenuse is the biggest side. That's why you're multiplying by these. So I use numbers. If this is 1 and this is 1, the hypotenuse is radical 2 times 1, which is just 1 radical 2, and you can get rid of the 1. Just call it radical 2. And that's how you do 45, 45, 90. So what if this was a 4? Then this is a 4, because they're the same. It's isosceles. And what would the hypotenuse be? 4 radical 2. Okay, so in this one, find the sine, cosine, and tangent of 30. So let's put 30 in here, 60 in here, 90 in here. It's a 30, called a 30, 60, 90 triangle. And they said they want you to find the sine, cosine, and tangent of 30, which means this is the opposite side. It means this is the adjacent side, and this is the hypotenuse. So if it's a 30, 60, 90, it has special sides. What's across from 30? 1. It's a short leg. What is the hypotenuse? It's double the short leg. So it's 2. And what is the long leg? It says right there to take radical 3 times the short leg. So it's 1, 2, and radical 3. So what is the sine of 30? What is the cosine of 30? And what is the tangent of 30? Well, the sine of 30 is opposite over hypotenuse. So it's 1/2. The cosine of 30 is adjacent over hypotenuse, which is radical 3 over 2. And the tan of 30 is opposite over adjacent, which is 1 over radical 3, which we are going to rationalize the small ones like this. So you should multiply top and bottom by radical 3 to get this. Now on your calculator, punch in, if you're in degrees, make sure you're in degrees, punch in sine 30. You should get 0.5. If you press in cosine of 30, you should get 0.866, because that's what radical 3 over 2 is. And that's also what cosine of 30 is. Tangent of 30 is radical 3 over 3. I think that's like 0.577, because that's what radical 3 over 3 is. But that's also what tan of 30 is. Why is this important? We're going to be learning the unit circle here coming up. All of these angles that I have just drawn here are 30 degrees away from an x-axis. So this first one is 30 degrees. Its special ordered pair on the unit circle is going to be, it's always in the order cosine, sine, and then tangent's going to be on the outside. So the cosine of 30, it says right here, is radical 3 over 2. So you fill that in. The sine of 30 is 1/2. That goes there. And the tangent of 30, from our little problem here, is radical 3 over 3. And you're going to have to memorize that order pair, because that order pair is the same thing on all parts. So what's 180 minus 30? Did you guys say 150? So 150 has the same ordered pair. Cosine, sine, tangent. Except, something you learned last year is all scholars take calculus. Only sine is positive in this quadrant. So the sine is the second one. That means the other two are negative. So 180 plus 30 is 210. So 210 has this same ordered pair, but only tangent is positive in the third quadrant. Tangent's on the outside, so that means the other two are negative. Now, really quick, type in sine of 210. You should get negative 0.5 because that's what it's saying right there, is that it's negative 1/2. And then 360 minus 30 is 330. It has the same ordered pair. And that, in this little quadrant here, all scholars say calculus, C represents cosine. That means cosine's positive. That means the first one's positive. That means the other two are negative. That's why that order pair is important. These little three values actually are 4 times in the unit circle. They're 4 times in the unit circle. So let's do a 60. 30, 60, 90. Remember, 30 has a 1. The hypotenuse is double that. The long leg is radical 3 times the short leg. So there's your sides. But this time we're going from 60, so circle 60. So across from 60 is the opposite. Next to 60 is the adjacent. And the long leg, the 2, is always the hypotenuse. So what is the sine of 60? What is the cosine of 60? And what is the tangent of 60? Well, sine is OH. Okay, so sine of 60, OH. It's radical 3 over 2. Cosine of 60 is AH, 1 over 2. Tangent of 60 is opposite, which is radical 3 over adjacent, which is 1. These are your 3 special sides of a 60. So in the unit circle, 60 is up here. Guess what ordered pair goes with that? Well, it goes cosine, which is 1/2, then sine, which is radical 3 over 2, then tangent. Let's compare this to the one we just did. Do you see how it's just a flip? This one was radical 3 over 2, 1/2. This one's 1/2 radical 3 over 2. It's just a flip. Anyone know what 180 minus 60 is? Hopefully you're saying 120. So if you put 120 in here, it has the same ordered pair. But only sine is positive, so cosine and tangent's negative. We're going to be doing all this stuff in the next couple days. 180 plus 60 is 240, so it has the same ordered pairs. But only tangent's positive. So just do me a favor right now. Type in cosine of 240. Cosine of 240, you should get negative 0.5 because there it is. And 360 minus 60 is 300. It has the same ordered pair, but only cosine is positive. It has the same tangent. So all this stuff's coming, 30s, 60s. These order pairs you're going to have to know. And the last one is 45. This is the next order pair you have to know. In a 45, 45, 90 triangle, your legs are the same. We're going to call them 1 and 1. The hypotenuse is radical 2 times the legs. Fill in those sides. This is stuff you're supposed to know from geometry. And they want to know what the sine, cosine, and tangent of 45 is. It doesn't matter which angle you go from. They're both the same. So I'll just go from this one. So we'll say this is the opposite, this is the adjacent, and this is hypotenuse. So we have sine of 45, cosine of 45, tangent of 45. Well, the sine of 45 is opposite over hypotenuse, which is 1 over radical 2. Can you guys rationalize that? Multiply top and bottom by radical 2. So it's radical 2 over 2, which, by the way, is about 0.707. So if you typed in sine of 45, you should get about 0.707, because that's what radical 2 over 2 is. The cosine of 45 is the same thing. Now, the tangent of 45 is great. It's the best one there is. Tangent of 45 is opposite over adjacent. Opposite is 1, adjacent is 1. So the tangent of 45 is 1. Punch that in your calculator. Tangent of 45 is 1. So in the unit circle, 45s are here. I know this is a terrible unit circle, but here's 45. Its ordered pairs are radical 2 over 2, radical 2 over 2, and 1. The cosine of 45 is this. The sine of 45 is this. The tangent of 45 is 1. So if you come over here, 180 minus 45 is 135. It has the same ordered pair. But only sine is positive here. The other two are negative. So you put negatives in there. 180 plus 45 is 225. But only tangent's positive, so both the x and y, cosine and sine, are both negative. And 360 minus 45 is about 315 and has the same ordered pair. But only cosine is positive. That means that's negative and that's negative. And this is the kind of stuff we're going to be doing the next couple of days. So you're in a circle. So getting ready. Goodbye. Have a good night.